Hello everyone, I am Vijay from CSM department in Srinivasa Ramanujan Institute of Technology. Today I am going to discuss a very important topic in chemistry, that is construction and working of zinc air and lead acid batteries. Let us see the overview of the today's topic. Here firstly we discuss the introduction of the batteries, and we discuss zinc air battery overview, construction of zinc air battery, working principle of zinc air battery, applications of zinc air battery, advantages and limitations. And following this, we also discuss another battery, that is lead acid battery overview, construction of lead acid battery, working principle of lead acid battery, applications of lead acid battery, comparison between these two batteries, that is zinc air and lead acid batteries, and we conclude the topic with conclusion. Let us discuss one by one. Let us see the introduction of batteries. Here, the batteries are the electrochemical devices that convert chemical energy into electrical energy. In this presentation, we discuss two common batteries, that is zinc air battery and lead acid battery. These both batteries, zinc air and lead acid batteries, have unique construction and applications in modern technology. Zinc air battery overview. The zinc air batteries use oxygen from the air and zinc metal as the anode. They are lightweight, high energy density batteries. These zinc air batteries are used in hearing aids, electric vehicles, and backup systems. Let us see the construction of zinc air battery. The components involved in the construction of zinc air battery is: for anode we use zinc metal, for cathode we use porous carbon with a catalyst. The electrolyte used here is aqueous potassium hydroxide or sodium hydroxide. These are the components used for the construction of zinc air battery, and let us discuss the working principle of zinc air battery. In the working principle of zinc air battery, at anode the following reaction takes place, that is Zn gives rise to Zn plus 2 plus 2 electrons. At the cathode the reaction is O2 plus 2H2O plus 4 electrons gives rise to 4OH minus. The overall cell reaction is 2Zn plus O2 gives rise to 2ZnO. The electrons flow from the zinc anode to the air cathode by generating electricity. By the flow of electrons from the anode to the cathode, the electricity generates. It is the principle of zinc air battery, and in the figure you clearly observe it. Here we are earlier discussed the air oxygen is taken from the outside to continue the process. Let us see the applications of zinc air battery. This zinc air battery is used for many purposes in household and industrial. Let us see some of these. For hearing aids, we use zinc air battery. For electrical vehicles, also we use zinc air battery. For remote sensors, we use zinc air battery. For backup power supplies, we use zinc air battery, and also for medical devices, we use it. Let us see the advantages. Here, some of the advantages are given for the zinc air battery. That is, it is a high energy density battery. It is very lightweight battery, and it is environmentally friendly. That is, it cannot release any harmful gases to the environment like CO2, NH3. It the limit Some of the limitations of there for this zinc air battery is it is non-rechargeable. That is, the zinc air battery once used it cannot be reused. It cannot be recharged. It is used for a once in a time, and it is sensitive to humidity and airflow. Let us see the overview of the lead acid battery, that is also a very important battery. The lead acid battery is a rechargeable battery. It was invented in the year 1859 by the scientist Gaston Plante. It is widely used in automobiles and UPS systems due to low cost and reliability. Let us see the construction of zinc lead acid battery. The main components involved is: for the positive plate we use lead dioxide, that is PbO2. For the negative plate we use sponge lead, that is Pb. Electrolyte here used is dilute sulfuric acid, and the formula of sulfuric acid is H2SO4. A separator and a container is also used in the construction of lead acid battery. Let us see the working principle of lead acid battery. For the discharging, the following reaction takes place. Here Pb plus PbO2 plus 2H2SO4 gives rise to 2PbSO4 plus 2H2O. Charging means reverse process. That is, by reversing the following reaction, we get the charging reaction. That is 2 PbSO4 plus 2 H2O gives rise to Pb plus PbO2 plus 2 H2SO4. Here the chemical energy is converted to electrical energy during discharge, and it is reversed. That is, electrical energy is converted into chemical energy while charging. In the figure you clearly observe the working principle, the charging reaction of lead acid battery. Here cathode, anode and used. PbSO4 is used. Here electrolyte uses to H2SO4. See, let us see the applications of lead acid battery in our daily life and industrial purposes. We use lead acid batteries in automobiles, inverters, and UPS. For emergency lighting, we use lead acid batteries. Power backup systems, renewable energy storage. Let us compare these two batteries, zinc air and lead acid batteries. Firstly, the zinc air battery is lightweight and lead acid battery is heavyweight. It is high energy density battery, whereas the zinc lead acid battery is low energy density. The zinc air battery is mostly non-rechargeable. That is, we can't once we use it cannot be recharged. But the lead acid battery is rechargeable. We can use many number of times the lead acid battery by charging it and reusing. That's why by recharging content it is lower energy density. Without recharging it is high energy density. It is low cost. Lead acid battery is low cost. These both batteries are crucial for various energy. Conclusion: zinc air and lead acid batteries play a vital role in portable and backup power systems. While zinc air is compact and high capacity, lead acid remains a robust rechargeable option for heavy duty applications. Thank you.